All right, today we're going to look at solving quadratic equations by factoring. So this time, this lesson is going to have a coefficient of greater than 1 in front of the squared term. So in this case, you can see it's 3r squared minus 16r minus 12 equals 0. Remember, we are finding the x-intercepts of the parabola of the graph, but we're doing it without graphing. So we do our diamond here, and we take 3 times negative 12, and that goes here. So it's negative 36 in the top of our diamond. And the middle term, negative 16, goes in the bottom of our diamond. And to complete our diamond, the factors of 36 that would work would be 2 and 18, all right, because 2 times 18 is 36. However, we needed to add to a negative 16, so 18 will have the negative. All right, now if you remember, we looked through here, we didn't have a GCF, so we went right for our diamond. So now we're going to take the first term, 3r, without the square on the r. That is how we factor these problems when we have a coefficient of greater than 1. All right, so we're going to take our diamond, though, to complete it, so plus 2. And again, the next factor is going to have 3r again. All right, so we're always looking at that first term. And then it's minus 18, and it still equals 0. Because remember, all quadratics must equal 0, so you're going to keep that equation all the way down. Now, you look through here, and since we didn't have a GCF, we won't be losing anything, and this has to be reduced. All right, so you must learn to reduce that. If you haven't been doing that or forgetting that that's what you have to do. So we have 3r plus 2 for our first factor, because that's not reducible. This one reduces by 3. So 3 divided into 3r is r, and 3 divided into 18 is 6. And those are our factors. Now, just like we learned in the first video, when we had a equal to 1, we will now set each of these factors equal to 0. So we have this, and we're going to solve for r. So we subtract 2 on this one. We have 3r equals negative 2. We're going to divide by 3. So r equals negative 2/3. You will wind up with fractions, and that's okay. So don't freak out if you get a fraction. Okay, just check your numbers and your signs and all that, and make sure that you have the right factors. This one we're going to add 6 and add 6. Okay, and r equals 6. Okay, so our two answers are r equals negative 2/3 and 6. Okay, so those are our two x-intercepts of where our parabolas would cross the x-axis. All right, next problem. All right, because we're going to look at about 5 of them today because they come in all kinds of varieties. All right, remember, all quadratics must equal 0. All quadratic equations must equal 0. So this one doesn't, so force it. So we're going to bring that 7 to the other side so that we can get this to equal 0. Now 7 is not combinable with r squared or r, so we're going to write it out as 7r squared minus 14r plus 7. This is 0, so it has to equal something. You can't lose that side. All right, now we're going to factor. The first thing we start with is a GCF. And 7, 14, and 7, we have a 7 for a GCF. So we pull it out. It's just a number. And so that becomes r squared minus 2r, and that's plus 1 equals 0. All right, now what you want to do is you want to factor the trinomial. So factor this some more. So now you use your diamond. There's a 1 in front of this r squared. So 1 times 1 is 1. That goes in the top. Negative 2 goes in the bottom. Factors of 1 that can add to 2 are 1 and 1. They'll both be negative because we want them to multiply to a positive 1 but add to a negative 2. All right, so that's good. Now we keep our 7 GCF. We don't lose him. He's part of the factorization. R, and it's minus 1 here. And r, again, you only take the variable without the power, and since it's a 1, it's just 1r each. Minus 1 equals 0. Now these factors r minus 1, these are the same. Because they're the same, you only have to solve one time, which is good. Half the work. Now the 7 we can't solve because there's no variable here, so you leave it. It's a multiple, so leave it. Doesn't affect anything. We're trying to find out what the values of r will be. So since we have r minus 1 twice, we will only do this once because it's repetitive. And r equals 1. Now, what's wild about this is that you only have one x-intercept. So we need to think. Okay, what would that look like? There's our x-axis, y-axis. This is our parabola. It's very, very narrow because it's 7 times the parent in as far as its y values. But since we only have one y-intercept, that means that the y-intercept means that it's 0 for y, so it's not going up or down here. But r is 1, so where r is 1, okay, that is something what our parabola would look like. So this x-intercept is only one of them because it's the vertex. So whenever you wind up with one x-intercept, it will only be the vertex that is touching the x-axis. Next problem. All right, like I said, come in all shapes and sizes. 36w equals negative 324w squared minus 1. A lot of us might skip this problem because we see 324, and that's like crazy. So again, what we do is we bring over everything to the left side. Now I'm going to bring this over to the left side because I don't want this to be negative. So I'm going to bring it over here. Okay, so I'm going to get 324w squared plus the 36w, and it still equals to negative 1 because this guy wiped out. Again, all quadratics must equal 0, so I'm going to bring that 1 over now, and that's a 0. So we have 324w squared plus 36w plus 1 equals 0. Okay, now, because of that, what we are looking at is that we can't take any GCFs out because of this 1. It's number 1. You can't take anything out. So when we have this situation, take a look at this one and see if it's a perfect square. That's what you want to ask. Perfect square? So you get out your calculators, you take the square root of it, and see what the answer is, okay? Because that's going to help us. So let's get our diamond ready. 324 times 1, 324. This is 36, okay? So with that, we're looking at whether 324 is a perfect square, and when we do this problem, we find out it is. The square root of 324 is 18. So 18 and 18 are going to go here and fill in our diamond. All right, so now what we're going to do is we're going to build our factors. So 324w, it's a large number, I know, plus 18. And 324w again plus 18 equals 0. Now, we already know that 324 is divisible by 18 because we just did that. 18 times 18 is 324. So factor out and reduce this, okay? And reduce this. And you're going to get 18w plus 1. You're going to get 18w plus 1. And it equals 0. So since they're both the same, we'll take it one time and we'll solve. Now nobody said it's going to be a pretty answer. 18w equals negative 1. Divide by 18, divide by 18, and w equals negative 1 over 18. Again, there's only one answer for w. It's a vertex point, but that is where your parabola would cross the x-axis. Or that is the answer for w, negative 1 over 18. All right. Okay, what do you do with something like this? There's only two terms, and the d squared is on the right-hand side, and it's negative. Again, our quadratics must equal 0, so we're going to bring that d squared over to the other side. So we have d squared minus 25 equals 0. That zeroes out. All right, now, there's two things that goes on here. One, we're missing a middle term. All right, we're missing the d term, the middle term. which means that we could potentially have a difference of squares. So that's what we want to look at. So d times d gives us d squared, and 5 times 5 gives us 25. So those are perfect squares. And this is a difference sign. Okay? So difference. So this is a difference of squares. Now we learned how to do this in factoring when it was not an equation. So we could easily now just do this. D minus 5 and D plus 5. Different signs, difference of squares. Okay? An alternative is, okay, this is a big OR. You can do your diamond. Okay, you have D squared plus 0D minus 25 equals 0. So your diamond is negative 25 on the top, 0 on the bottom, 5 and negative 5 would work, giving you still D minus 5 and D plus 5 for your factors. And now when you solve, D minus 5 equals 0, so D equals 5 by adding each other over. D plus 5 equals 0, subtract the 5, subtract, and D equals negative 5. And those are your two answers, positive and negative 5. And last but not least, what if we have something similar to that, but we have to take out a GCF maybe. So again, we're going to bring this 75x squared over to the left. We want the quadratics must equal 0. So we're going to get 75x squared minus 48 equals 0, because that guy goes away, but you have to maintain the balance of the equation, and you can't lose the other side. Okay, so now we're going to look for GCF as always, okay? And here, 75 and 48, 2 doesn't work, 3 does. Try going higher to 4, 6, and they don't work. So I will take out a 3 as a GCF, and I will have 25x squared minus 16 equals 0. And here, because these numbers are pretty large, 25 and 16, I would really look and say, hey, listen, I'm missing my middle term, okay? Middle term is gone. Missing, okay? And because it's missing, I want to look for a difference of squares. That's what I'm questioning. Difference of squares? And the reality is, yeah, it could be 25. Okay, this will break into 5 times 5. So this would be 5x times 5x because it's x squared also, right? It's 25x squared. 16 is 4 times 4. And this is the difference. That's a subtraction sign. So therefore, our answer is going to be 3 times the quantity of 5x minus 4 and 5x plus 4 equals 0. Now 3 is a multiple, so ignore it. And we take each of the factors that contain the variable to solve. So we take 5x minus 4 equals 0. We solve by adding 4. 5x equals 4. Divide by 5. So x equals 4/5. Take the other one, 5x plus 4 equals 0. Subtract the 4. 5x equals negative 4. Divide by 5. X equals negative 4/5. So these are our answers, positive and negative 4/5. So you are definitely going to wind up with fractions. There's no doubt about it. And, you know, go with it. I mean, if your numbers and calculations are right as far as your factoring, you will get some fractions. And they could be pretty ugly, okay? Pretty wild looking. All right? And that's how you do this.